Good morning to everyone. Today we discuss carbon family. As already we peoples know, carbon belongs to P block elements. First of all, we should know the elements present in carbon family. Carbon is the head of the member of its group. Followed by carbon we have silicon, germanium, tin. Tin is the chemical name, but we are using Latin symbol. In Latin, tin is called stannum, Stannum. Next to tin we have lead. Lead is also a chemical name, but we are using Latin symbol. In Latin, lead is called plumbum, Plumbum. Finally, we have highly unstable radioactive element Phalarovium. Electronic configuration of carbon group elements. Atomic number of carbon is 6. Its electronic configuration is helium configuration 2s2 2p2. Atomic number of silicon is 14. Its electronic configuration is neon configuration 3s2 3p2. Atomic number of germanium is 32. Its electronic configuration is argon configuration 3d10 4s2 4p2. Atomic number of stannum, that is tin, is 50. Its electronic configuration is krypton configuration 4d10 5s2 5p2. Atomic number of plumbum, that is lead, is 82. Xenon configuration 4f14 5d10 6s2 6p2. Atomic number of Phalarovium is 114. Its electronic configuration is radon configuration 5f14 6d10 7s2 7p2. Therefore, the general electronic configuration of carbon group elements is ns2 np2. Valencies. All members of this group are tetravalent, that is, all the members of carbon group elements shows +4 oxidation state. In addition, they show divalency, that is +2 oxidation state. The stability of the divalent state, that is +2 state of carbon group elements, increases as we move from carbon to plumbum, that is lead, because of inert pair effect. Divalent carbon species, that is namely carbene CCl2, exist only as reaction intermediates. They are unstable. Silicon dihalides are stable only at a high temperature. For lead, +2 state is the stable oxidation state. What is meant by an inert pair effect? The inert pair effect is the tendency of the two electrons in the outermost atomic s orbital to remain unshared in compounds of post-transition metals, that is metals of p block elements. As a result, the inert pair of ns electrons remains more tightly held by the nucleus and hence participates less in bond formation. Catenation. Definition: the formation of molecules with chains of atoms of a particular element is called catenation. Among the periodic table, carbon shows maximum catenation property. Silicon has a tendency towards catenation but not as much as carbon. Germanium and tin shows low tendency towards catenation. Lead has no tendency towards catenation. Greater the strength of the element-element bond, greater is the tendency of catenation. Carbon-carbon bond strength is more when compared to silicon, germanium and tin. Therefore, degree of catenation for carbon is extensive, whereas silicon, germanium and tin undergo limited number of catenation. Oxides of carbon group elements. All the members of carbon group elements forms two types of oxides. One is monoxide of the type MO. Here M indicates carbon group elements. Dioxide of the type MO2. Carbon monoxide, silicon monoxide, germanium monoxide, tin monoxide, lead monoxides. Carbon monoxide is neutral, silicon monoxide is acidic, germanium monoxide is basic, tin and lead monoxides are amphoteric. Dioxides of carbon group elements. Carbon dioxide and silicon dioxides are acidic. Germanium, tin and lead dioxides are amphoteric. In general, acidic character of oxides of carbon group elements decreases and basic character increases as we move down the group. Lead also form an oxide of the type Pb3O4, which is a mixed oxide of 2 moles of lead monoxide and 1 mole of lead dioxide. It can be written like this: 2PbO.PbO2. Carbon forms several oxides. Carbon monoxide and carbon dioxides are extremely stable. Carbon suboxide C3O2, pentacarbon dioxide C5O2, dodecacarbon nanoxide C12O9. These three oxides are less stable. Dicarbon monoxide C2O and carbon sesquick oxide C2O3. These two oxides are unstable for carbon. Carbon dioxide is a gas while silicon dioxide is a solid. Why? Carbon atom has small radius 0.77 Armstrong unit, so the positively charged nucleus attracts the binding electrons very strongly and does not permit the oxygen atom to combine with another carbon atom. But silicon atom has a larger radius 1.17 Armstrong unit, so the positively charged nucleus does not attract the binding electrons strongly. The oxygen atom is a shade between the two silicon atoms. This leads to the formation of a giant SiO2 molecule. Therefore, silicon dioxide remains a solid as this linking is not possible in carbon dioxide. It remains as discrete molecules and so remains as gas. This is the structure of silicon dioxide, 3D silicates. Halides of carbon group elements. All the elements of this group form tetrahalides of the type MX4, which are mostly covalent. Tetrafluorides. All the members of carbon group elements forms tetrafluoride. Carbon tetrafluoride gas phase covalent in nature, silicon tetrafluoride gas phase covalent in nature, germanium tetrafluoride gas phase covalent in nature, tin tetrafluoride solid phase ionic in character, lead tetrafluoride solid phase ionic in character. Tetrachlorides. All the members of carbon group elements forms tetrachlorides. Carbon tetrachloride colorless liquid, silicon tetrachloride is also a liquid, germanium tetrachloride is also a liquid, tin tetrachloride hygroscopic liquid, lead tetrachloride yellow oily liquid. Except lead, the left of the carbon group elements carbon, silicon, germanium, tin forms tetrabromides. Except lead, the left of the carbon group elements forms tetraiodide. Dihalides of carbon group elements. Carbon form only one dihalide of molecular formula CCl2. Already we have discussed CCl2 is called carbene, unstable, obtained in some organic reaction intermediate. The dihalide of germanium, tin, lead are more ionic than covalent character. The stability of dihalide is in the order: carbon dihalide is the least stable, lead dihalide is more stable. Formation of complex halides. Carbon tetrahalide does not form complex halide due to the unavailability of d orbital, whereas the left of the tetrahalides of carbon group elements like silicon, germanium, tin and lead form complex halides due to the availability of d orbital. These elements can increase their coordination number from 4 to 6. Oxy acids of carbon group elements. The most important oxy acids of carbon is carbon monoxide. 1 mole of carbon dioxide in gas phase dissolved in water, it forms carbonic acid. The equilibrium shift to the right, that is towards aqueous carbonic acid, on increasing the pressure of carbon dioxide. Carbonic acid is unstable, it cannot be isolated. It forms two series of salts. In aqueous solution, carbonic acid gives 1 mole of H plus ion and convert carbonic acid to bicarbonate anion. Now in aqueous solution, the bicarbonate anion dissociate to carbonate anion. Therefore, carbonic acid is a dibasic acid. It gives 2 moles of H plus ions. If carbonic acid lose 1 mole of H plus ion, carbonic acid converted to bicarbonate anion. Now the bicarbonate anion, after losing another H plus ion from bicarbonate anion, in aqueous solution, the bicarbonate anion convert to the bicarbonate anion converted to carbonate anion. Therefore, carbonic acid forms two series of salts: bicarbonate, example sodium bicarbonate; carbonate, example sodium carbonate. Carbonic acid decomposes to carbon dioxide on standing. Aqueous solution of carbonic acid on standing decomposes to give water plus carbon dioxide. Silicic acid. Silicon tetrafluoride on hydrolysis forms silicic acid. Its chemical formula SiOH 4 times, or you can write H4SiO4, or we can write SiO2.2H2O. 1 mole of silicon tetrafluoride on hydrolysis with 4 moles of water molecule, we get 1 mole of silicic acid of chemical formula H4SiO4 or SiOH 4 times or SiO2.2H2O plus 4 moles of hydrofluoric acid. Silicic acid of different formulae are formed in solutions from silicon dioxide and water at high temperatures and pressure. None of the silicic acids is stable. The following are some such silicic acids which exist only in solution. Orthosilicic acid chemical formula H4SiO4, disilicic acid chemical formula H2Si2O5, metasilicic acid chemical formula H2SiO3, pyrosilicic acid chemical formula H6Si2O7. Thank you.